Welcome to the 2022 weather recap and the 2023 forecast. I'm Russ Qualls, and I'm the Idaho State Climatologist. In agriculture, precipitation is one of the key weather variables, whether directly on the ag land itself or accumulating snowpack in the mountains to provide runoff for spring and summer water supply. In any given location, whether there is a surplus of precipitation or deficit leading to drought, it is measured relative to the usual average or normal annual precipitation for that location. This map shows the 30-year normal annual precipitation across the U.S. Some areas, such as the Washington and Oregon coastal areas and Cascade Range, can receive in excess of 60 inches per year, the highest anywhere in the U.S. In Idaho, normal annual precipitation ranges from less than 8 inches in some pockets of the Snake River Plain to as much as 80 inches in the northern mountains. The U.S. Drought Monitor, available online and updated weekly, provides categorizations of drought across the U.S. The Drought Monitor maps use a warm color scheme to indicate the degree of severity of drought. Yellow colors, starting with the lowest level of drought, to tan, then orange, then red, and then finally brown, indicate increasing severity. The Drought Monitor also distinguishes between the time frame of drought. Short-term drought, generally less than 6 months, can come into play quickly if precipitation falls well below average, and can also end abruptly if precipitation picks back up. Shallow soil moisture required for grasses and other short-rooted plants can be thought of as a good surrogate for short-term drought. Shallow soil can both dry out and be replenished quickly by a deficit or surplus of precipitation in the short term. Long-term drought, longer than 6 months, can be thought of as a hydrologic drought, such as abnormally low reservoir storage, especially when the deficit persists for more than a year. The map indicates the type of drought with an S for short and L for long, delineated with a heavy black line. Both short and long-term drought can be present simultaneously in a given location. Let's take a look at drought, focusing on the Northwest, starting early last fall, when the entire Northwest was engulfed in drought, ranging from abnormally dry or yellow to exceptional drought, represented by brown, largely resulting from the extremely high temperatures across the region during the summer of 2021. I'm going to scroll through a series of these images, jumping forward about a month at a time to show the progression of drought. Early October, late November 2021, early December, January 2022, February 2022, March 2022. Notice the increase in drought categorization here, especially in southern Idaho in April. This happened partly because of a pause in the accumulation of mountain snowpack during the winter from January through March, and we're beginning to get near the beginning of the melt season and being concerned about lack of snowpack. However, in May, instead of heading directly into the melt season, things cooled off and we got a bit more precipitation again, lasting through June. And that kind of held off some of the onset of the drought due to the lack of precipitation in the winter. We're going to take a look at this in a little bit with regards to the mountain snowpack. So here in June, the cooler temperatures delayed the snowmelt, and along with a little bit of precipitation, helped retain the snowpack, and the drought categorizations were backed off just a little bit. Here's the beginning of July. And here in August, the drought conditions across the state weren't bad, certainly much less severe than they were the previous fall. And even though July and August were pretty dry, the delayed melt because of the cooler conditions in May and June really helped a lot. Finally, here in September, we begin to see the effects of the dry, warm summer. Here you see the continuing expansion of the drought conditions across the Northwest through September. Here on September 20th, you see further expansion of that D1 moderate drought in tan, pushing northward into north-central Idaho. In late September, a big slug of precipitation came through north-central Idaho, and we pulled back the D1 category a little bit, and there was a little bit of deepening of the drought in southern Idaho. October 18th, a little bit of expansion of D1 in northern Idaho. Here's November 1st, November 8th, and November 22nd. Here on this latest drought monitor map from last week on December 6th, there's a little bit of a pullback of drought in southeastern Washington and western northern Idaho. There's been some fall precipitation beginning, but we don't like to pull the drought categories back too much during this early part of the winter season because a lot can change by the spring. Before I move on to snowpack, I want to take a moment to put in a plug for a volunteer opportunity to collect precipitation measurements at your location through an organization called CocoRa's. You can begin to collect daily manual precipitation observations at your location and enter the data through an online portal. Your observations are shown in a nationwide map next to other observations across the U.S. Joining CocoRa's not only provides a record for you to refer back to, but also provides valuable information to the National Weather Service to formulate severe weather alerts. The National Weather Service receives a direct feed from CocoRa's when your observations provide information about a significant rainfall, snow, hail, or other weather event. There's also a condition monitoring report as shown on the right side of this slide that you can file to provide information to the U.S. Drought Monitor, which they can use to determine drought categorizations. For further information, go to cocoras.org, shown in the top left corner of this slide. Now I want to shift to mountain snowpack. The Natural Resource Conservation Service, or NRCS, measures snow at stations they refer to as snow telemetry or SNOWTEL stations. There's a bunch of them distributed throughout the Northwest in mountainous areas. They measure the depth of water and snow as if the snow were melted, called snow water equivalent, or SWE. You can get an idea of how the SWE at a station on a particular day compares with the historical record at that station by taking its ratio with respect to the 30-year median SWE values for that same day. A large ratio expressed as a percent says the observed value is larger than normal for that date. These station percent of media SWE can be averaged over a basin. Now this image is from October 31st, 2021. That was near the beginning of the water year last year. A water year runs from October 1st of one year through September 30th of the next, and is referred to by the year in which it ends. So the water year from October 1st, 2021 to September 30th, 2022 is the 2022 water year. What you can see here is that near the end of October, the water year had started out fairly well, at least in central and southern Idaho, with more than 200% of the 30-year median values of SWE. This was partly due to some atmospheric rivers having come in and hit central and southern Idaho early in the snow season. However, last November, temperatures warmed up a little bit, and some of the snow accumulation that arrived in October had melted, and there was minimal new snow, so that the high October 31st percentage of snowpack relative to the median had tapered off quite a bit by the end of November. Now that's not necessarily a big problem. Early in the season, the amount of snow accumulation, even in the median, is usually relatively a small portion of the annual snowpack that you would expect by mid-April. And so you can see large fluctuations in the percentage of median SWE early in the season. As you can see here, that deficit of snow from late November had really corrected itself by December 31st, so that the end of the year last year on December 31st, the snowpack was looking pretty good across most of the state. At the end of January, the percent of median SWE weren't as high as they were at the end of December, but they were still looking pretty good across most of the state, with the exception of Oahe and Brunei basins in southwestern Idaho. At the end of February, the snowpack in northern Idaho still looked pretty good, but many of the basins encircling the Snake River Plain were beginning to look concerning. At the end of March, the snowpack was beginning to raise concern, especially in southern Idaho. Snow begins to melt across most of the state sometime in April, so April 1st SWE is usually a good measure of what we can expect from the snowpack across the state. And on April 1st last year, things didn't look really great. In this view, instead of showing basin percent of median SWE, I show the values for individual stations. Many of the stations were at only 50 to 75% of median SWE on April 1st. To take a look at how we got to where we were last spring, let's take a look at the values from an individual station. This is the Elk Butte station located at elevation 5,690 feet in the Clearwater Basin. And this image shows, instead of a map like we were looking at, a time series. So we have month beginning in the water year in October 1st of 2021 and continuing through the whole season in this last spring. And this image shows pretty much the collection of all of the data. The green line that this arrow points to represents the median value for each day over a 30-year period from 1991 through 2020. And so it represents kind of a middle of the road value of snowpack for the year. The lower value on the bottom end, this red line, is the minimum value that was observed during that 30-year period, and the top purple line represents the maximum value observed any day or observed on each day throughout the period, that 30-year period. Now, the yellowish line that has the star sitting on top of it, indicated, pointed to by this, the lower of the two long arrows, indicates the 2022 water year. So it starts in October 1st, 2021, and it moves across the image. And this kind of shows a little bit of how we got to where we were on April 1st last year. The star shows the value of that curve on April 1st. It was about maybe 26, 27 inches of snow water equivalent on that day, compared to about 35 or 37 inches of snow water equivalent that represents the median for that day. And to kind of see how we got there, if you look back to early January, we were doing okay back then. But then after about January 7th or 10th, the new precipitation just kind of curtailed off, and it grew slowly a little bit through April, but certainly fell far below what the median value has done during that same 3-month period. And that ended up with us being pretty low, in this case at about 74% of the median value on April 1st. And but if you look following that, what happened was, instead of this beginning to kind of drop off, like the median around then begins to drop off, this one actually increased a little bit coming into late April, and then kind of persisted. It didn't begin to melt very quickly coming into May until about maybe the middle of May. And then you see it starts to taper off. But what that does is it carries it beyond the median value. And so it actually goes from being below it to where it is above it here in late May. Here on April 30th, you see the effects of that slowdown in the melt and the little bit of extra precipitation that we saw in the Elk Butte station at the end of April. By the end of April, northern Idaho was looking pretty good. Southern Idaho still wasn't doing great, but it was better than it was doing at the beginning of April. Here at the end of May, Basin SWE continued to look really good, actually even better than it did at the end of April. This is largely due to the cooler conditions that delayed the melt, more so than any big influx of precipitation. Here in the middle of June, the percentage of median SWE kept going up, and again, this is largely because of the delay in the melt. I'll take a look at that in just a minute. Still good numbers here on June 19th, especially in the northern and eastern parts of the state. Here's June 23rd. And finally, by June 28th, a lot of the state's basins had melted out, but here in northern Idaho, a couple of basins were still holding on. Right at the end of the last slide, I marked a station called the Cool Creek Station. The reason I wanted to comment on this station is that the percentage of basin SWE at that point had gone up into several thousands % of the median. That's a little bit misleading at face value. On this slide, the median values are represented by the light green line, which the red arrow points to in late June. In the calculation of percentage of median SWE, the median value is in the denominator, so as it goes to zero, the percentage becomes very large. This doesn't mean that there's a huge amount of snow on the basin. However, it does tell us that the snow persisted longer than usual. All right, let's just jump forward real quick to this fall. October 20th is about 3 weeks into the new 2023 water year. At this point, things weren't looking really good, but it still was very early in the season, so it doesn't really matter that much. Here, just a couple of days later, a storm came through, and you can see how quickly the numbers change in terms of current percent of median SWE. Here on this slide, a week later on October 30th, the numbers have dropped down a little bit, not because the snow is melting, but because the median is continuing to increase steadily. The basic percent of median SWE continues to decline here on October 31st because the median continues to increase. Another storm came through the northwest the first week of November and dropped new snowfall of the mountains and bumped these numbers up. Early in the snow accumulation period, you can see how significant individual storms are to the basin percent of median SWE. Good numbers here again at the end of November. And here, just a couple of days ago, the numbers are looking pretty solid. This gives us reason to be cautiously optimistic for the snowpack this year, but it's still a little bit too early to be confident. I'll be talking about this in the next slide. Here's the time series plot of SWE of the Cool Creek Station in the Clearwater Basin, which we looked at earlier. Down in the lower left, I've encircled the black line representing the current water year SWE, which started on October 1st. The red and black arrows point to the December 10th current water year SWE, as well as the 30-year median SWE, which is the bright green line. For this particular year, they have similar values at present, but it's really early in the snow accumulation period, and less than a quarter of the total SWE needed to reach the April peak SWE of 46.5 inches, shown by the circled green X. A lot can change between now and April, so it's difficult to predict purely on the basis of this data how good the snowpack will be when the spring melt season arrives. Let's shift gears again and look at the forecast for the coming month as well as through the coming year. These are put out by NOAA's Climate Prediction Center. This first slide represents a 1-month forecast for December, which was released on November 30th. The map on the left represents temperature outlook, and the right-hand side represents the December precipitation outlook. In the temperature figure, you can see the cooler blue and grayish colors along the northern states, which indicate the likelihood that December will have temperatures below the 30-year normal here in Idaho. The precipitation map shows a forecast for precipitation to be above average in Idaho in December. Combined, this suggests that December is likely to have snowier conditions than normal. Advancing forward by 1 month, the February, March, April outlook again forecasts the cooler, wetter conditions will continue into the early spring. March, April, and May forecast indicates that the cooler, wetter conditions are beginning to recede out of Idaho. The April to June forecast indicates that there are equal chances of temperature and precipitation conditions being above, at, or below normal in Idaho. For the May through July 90-day period, the forecast shifts to above average temperature across the state and below average precipitation in the north. That forecast continues through June, July, and August. July, August, and September. Again through August, September, and October. And September, October, and November. The above average temperatures begin to recede out of the state to the south by the end of 2023. Okay, let's briefly review what we've talked about. In the fall of 2021, Idaho was engulfed in extreme to exceptional drought. This substantially lessened throughout 2022, particularly because of cooler, wetter conditions in May and June. But the hot, dry summer began to nudge the state back towards slightly worsening drought conditions in the fall, which has leveled off with recent accumulation of snow. The snow accumulation in the fall of 2021 started out well, but seemed to stagnate during January into April. However, cool, wet weather in May and June helped preserve the snowpack and prevent the drought which might have otherwise developed given the low snowpack in April. Finally, the Climate Prediction Center seasonal outlooks for 2023 suggest that a likely scenario might be cool, wet conditions through the winter and early spring, favorable for mountain snowpack accumulation. However, for late spring, summer, and fall, the outlook calls for warm, dry conditions, which might inhibit the complete elimination of drought from Idaho in 2023. This concludes the 2022 weather recap and 2023 forecast. Thank you for your time.